All right, let's talk about something that's running behind the scenes of pretty much every single app you touch. We're going to break down something called the three-level database architecture. I know, it sounds a little technical, but trust me, it is the secret sauce that makes everything in our digital world just work.
I mean, think about it. How on earth does that work? You've got the exact same database, the same single source of information, but it's showing two totally different pictures to two different people. It seems impossible, right? Well, it's not magic. It's just really, really clever design.
And that's where this powerful design comes into play. It's called the three-level architecture. And this is the whole reason modern databases can be so secure, so flexible, and honestly, just so incredibly powerful.
Okay, so first up, why bother with three levels? Why not just have one big file that everyone looks at?
Well, here's a great way to think about it. Imagine you're a teacher. You're not going to explain how plants work the same way to a group of first graders as you would to a room full of professional botanists, right? To the kids, you'd say plants need sunlight and water. Simple. But for the experts, you're talking about photosystem 2 and light wavelengths. The core topic is the same, but the presentation is completely different, tailored for the audience. A database has to do the exact same thing.
All right, let's dive into that top layer, the one you and I see all the time. Section 2, the user's view, which we call the external level.
Okay, so the external level, just think of it as a custom-made window into the database. It isn't the whole building, just the specific view that one person needs. It brilliantly hides all the other stuff, all the complexity they just don't need to worry about.
So let's take a university database. A student logs in, and what do they see? Their name, their roll number, their marks. That's their view. But then an HR manager logs into that same system. They see the student's name, sure, but also their department and salary. And then you have the bus coordinator. They need to see the student's address and phone number to plan routes. See? One database, three totally different, secure views, all tailored for each person.
So what's the point of all this? Well, first off, security. The student can't accidentally stumble upon salary information. It's also about simplicity. You only see what's relevant to you, no clutter. And here's the really cool part, independence. It means the big database in the background can change, but your simple little view can stay exactly the same. We'll talk a lot more about that in a bit.
Okay, let's move one level deeper. Section 3, the designer's blueprint. This is the conceptual level.
So, if the external level gives us all those different little windows, the conceptual level is the master blueprint for the entire building. This is the single source of truth. It defines literally everything, all the data, how it all fits together, all the relationships. It is the grand plan.
And what's actually in this blueprint? Well, you've got all your tables, like a student table and a course table. You've got every single column specified, like roll_no and name. It also defines what kind of data goes in there. Is it a number? Is it text? Is it a date? Crucially, it maps out the relationships between tables and sets the rules, things like age must be between 18 and 70. It is the complete logical picture of the whole system.
Time to go all the way down to the foundation. Section 4, how the data is actually stored. This is the physical level.
Right, so at this level, we're not talking about abstract ideas like tables anymore. We are talking about the real world, the nitty-gritty. How is this data physically laid out on a hard disk? We're talking about file structures, indexes to make things fast, how data is compressed or encrypted. This is the deep, deep technical stuff.
But here is the beautiful part. Users, they have no idea this level even exists. And honestly, even the database designers most of the time don't have to worry about it. The whole system is designed to hide this complexity. It's completely shielded from us, which is a huge relief.
Okay, next up, Section 5. This is where it all comes together, the magic of the system, data independence.
So we have these three separate layers, but what makes them so powerful is how they connect. Let's look at a classic problem. Let's say a user's app needs to show a full name, but in our database blueprint, we're actually storing it as three separate pieces: first name, middle name, and last name. Okay, now for the twist. A few months later, the business decides, you know what, we don't need middle name anymore. So the database admin removes that field. The big question is, does the user's application, which is still looking for that full name, just break?
The answer is no, and this is so cool. There's a kind of translator or a mapping between the user's view and that main blueprint. All the programmer has to do is update that mapping. The new rule is just, hey, full name is now first name plus last name. The user's application doesn't have to change one bit.
It doesn't even know a change happened. This is what we call logical data independence.
And this idea is so powerful, it also applies one level down. You get the same freedom between the blueprint and the actual physical storage. That's called physical data independence. It means you can do all sorts of things. Move the entire database to a new hard drive, add a new index to speed up searches. And guess what? The logical blueprint doesn't change. The user applications definitely don't change. It's a game changer for maintenance.
So let's wrap this all up. Section 6. Why this architecture matters. Why should you care? Okay, if you remember one thing, remember this restaurant analogy. The customer gets a menu, right? That's the external view. It's simple, it shows you what you need. Then you have the chef in the kitchen who has the master recipe for every single dish. That's the conceptual view, the complete blueprint. And finally, someone in the storeroom knows exactly which shelf every ingredient is on. That's the physical view. 3 different jobs, 3 different perspectives, all working together seamlessly.
And what does this all give us? Well, it boils down to these huge benefits. Data independence is the big one, giving us all that flexibility. But we also get incredible security, simplicity for our users, and it just makes the whole system so much easier to maintain and upgrade over time.
So let's end with a final question to bring it all home. Let's say IT decides to upgrade the servers, and they swap out the old physical hard drive for a brand new, super fast solid-state drive. What does the end user, the person just using the app every day, need to do?
The answer? Absolutely nothing. Not a single thing. They probably won't even know what happened, except maybe that the app feels a little snappier. And that, right there, is the real power, the genius of this architecture. It lets the system evolve and improve, all without ever disrupting the people who actually rely on it.